Alrighty. Thank you everybody for showing up on this Father's Day weekend, taking time out of your beautiful summer or nearly summer. I'm Conrad Ely. I'm a habitat restoration project manager with the Tillamook Estuaries Partnership. And I've been working on this project in an interim capacity since Gina Christensen left. Today we're going to be talking about the preliminary alternatives for the dike breach and setback dike alternatives on the Sitka Sedge Tidal Wetland project. We've got a lot to cover today, so I'm going to keep my introduction brief. I want to introduce Krister Lebrecht. He's going to be the new project manager moving forward, but I will still be involved in this project on the technical team and in the background. So you'll see me at all these meetings. But I'll turn it over to Noel. Thank you.
Hi, everyone. Noel Batchelor, Oregon State Parks ecologist, longtime participant in these hydrology studies and other stakeholder involvement processes. And I just want to keep my presentation super short. I don't have any slides or anything, but just to kind of recap how we got to where we are right now. And Hunter has a ton to cover, so I'll keep my part really short. So for those of you who aren't really familiar with this project or need a refresher, I would point you to our website. If you Google Sitka Sedge hydrology, it'll come up very easily. And that website has all of the background information for hydrological studies since 2017. So all of the background that you'll need to get up to speed or get refreshed are there. And then just to go back in time to how this all started, in 2014, Oregon State Parks acquired the Sitka Sedge property, and soon thereafter started a series of assessments of everything from ecology to groundwater to surface water to wildlife. And at the end of the completion of those assessments, we went into a phase of scoping alternatives for hydrological analysis, fish passage, and so on in the marsh. And in 2019, pulled together a technical team that was made up of subject matter experts and also representatives from the local community that went through all of the options that were then under consideration and weighed the pros and cons, heard testimony about the different types of effects that would be expected to everything from infrastructure to fish passage to wildlife to private property and infrastructure. And at the end of that process, kind of ended up with a set of pros and cons, a scoring and a basis that OPRD could use for making a decision moving forward with a particular alternative. And then in 2020, State Parks met with the Tillamook County Commissioners and with the Oregon Parks and Recreation Commission and also with OPRD executive leadership to go over those pros and cons and to try to find out what the course of action was moving forward. In 2020, our executive staff selected the setback dike as the alternative that was the best balance for all of the needs on the table, from ecology to fish passage to private property and infrastructure and so on. And since that time, we've really passed the torch to Tillamook Estuaries Partnership to find grant funding and to continue investigations with Hunter on setback dike alternatives and sort of trying to get a little bit more meat on the bones as to what exactly a setback dike alternative might look like here. So even though Tillamook Estuaries Partnership has taken over the lead on outreach and contracting and grants, State Parks still remains the decision maker in this process because State Parks owns the existing dike and most of the land where a potential setback dike could be located. As you'll see in Hunter's presentation today, he's done a lot of work on different setback dike alternatives and specifics around constructability, cost, and complications. And there are some complications out there with the setback dike that you'll hear more about. But as part of that process, ESA has investigated a couple of options that are kind of around the edges of a setback dike alternative. And OPRD wants to make clear that at this point in time, we are very focused on a setback dike alternative, having gone through our 2019-2020 process to vet that as the balanced approach in this situation. If it turns out that that alternative has fatal flaws, complications, something that makes us need to revisit things, That will be a stakeholder involvement process similar to what we had in 2019, so that all of the aspects that need to be considered, such as private property, infrastructure, ecology, fish passions, are all weighed again, and we have to find a fallback solution that finds that balance. After you've heard Hunter's presentation today and asked any questions that you have here in our time together, we also have a form on our website where you can send us any more comments that you might have in writing. So if you go to our website, near the top, there's a submit comments field where you can add your name or not. Anonymous is fine. And you can add whatever comments, questions, concerns, ideas, brainstorming that you might have that you would like us to consider as we move forward. We ask that those comments be delivered probably in the next 2 weeks. So we're kind of we'd like to keep things moving here. So we're gonna, in July and August, go back, Tillamook Estuaries Partnership, State Parks, and ESA, and go through all the comments that we received from this group and any other submitters, and see if there are things that we need to work into our analysis, things that are gaps or ideas that we've overlooked, and then add those to the analysis moving forward. And really, that's all I have to say. I'll keep it super short and hand it over to Hunter. Thank
you. Thanks, Noel and Conrad. Thanks everybody for coming out here today, and really excited to share with you all of the work we've been doing and some of our findings. We've kind of covered some of this, just introductions with Tillamook Estuaries Partnership, Oregon State Parks, and ESA. I'm here representing our firm. I'm just one of us here. Actually, my colleague Dan joined as well, but we have a team of engineers and modeling staff, ecologists, landscape architects that have been working on this project as well as structural engineering and geotechnical engineers as well on our team. I'm going to give a brief overview just for context. I know most people here probably do have good familiarity with the project, but we'll give a little bit of an overview. The main purpose today is to present the results of our alternatives analysis and 2D hydraulic modeling effort that we've undertaken. I will do a recap of the Tierra del Mar drainage system analysis. I did present that at the last town hall, which there is a video available to watch on State Parks Project website, but I will give a recap of that. And then move into discussion about the dike breach configuration and analysis we did around that, as well as maintaining the trail network, accommodating the trail while breaching the dike. And then really focusing a lot on the setback dike alternative locations that we've looked at, how each of those locations would perform under different hydrologic and hydrologic scenarios. And as Noel mentioned, get into some feasibility and constructability considerations, as well as long-term maintenance considerations for a setback dike. We will have time at the end for questions and discussion. And as Noel said, there is a comment submittal page on the OPRD website. The project page, as Noel said, go ahead and Google Sitka Sedge hydrology and you'll find it there, and the link is also provided there as well. So a lot of folks involved in this effort, from a number of staff from Oregon Parks and Recreation Department, folks from Tillamook Estuaries Partnership. Again, I'm Hunter White, Principal Civil and Water Resources Engineer with ESA. And again, we've got a lot of partners involved here. We held a tech team meeting with a group of about 15 experts in different fields and representing different agencies to provide perspective on the project as well. For those who don't know, the Sitka Sedge State Natural Area is just north of here a little ways, sandwiched in between Sand Lake on the north end and Tierra del Mar town on the south end of the project area. The park boundary is shown there in red. Why are we here? What's the purpose of this project? So the existing tide gate system and dike is failing. The current tide gate that's out there is actually completely missing now. As we started this project, there was some of the tide gate left, but at this point, the tide gate's completely gone. The box culvert itself is also being undermined due to erosion. The dike itself has deficiencies, low points that have settled, as well as areas of erosion. And the current culvert that's there is undersized. So it really results in very high velocities, challenges for fish passage, which is also leading to some of the erosion that we see. It restricts fish passage through the system, and one of the goals of this project is to improve fish passage into the creeks, Renicky Creek, Belts Creek, and No Name Creek, or the East Marsh. And currently the dike is only barely above king tides. There are low points that can overtop and would soon be at risk of further overtopping due to sea level rise. As Noel mentioned, during the 2019 project phase, we evaluated a dike breach option, a modern tide gate option of replacing the existing tide gate with a modern tide gate system, and ultimately, as well as the dike breach, adding in a setback dike that would replace some of the functionality of the outer dike, and really comparing all these to the no action alternative or the existing condition. Briefly, the pros and cons of those alternatives. The dike breach really does provide the highest restoration value, restoring estuarine processes and fish passage. But the cons there are that it would lead to more frequent tidal water levels reaching the south end of the marsh. Not higher water levels overall, but more frequently reaching those water levels. The modern tide gate could provide some benefit for fish passage, but it is still a compromised fish passage solution and really doesn't provide the full restoration potential of the marsh that we would like to see. And also, there would be significant repairs needed to repair the existing dike in order to make the system functional under a modern tide gate scenario. The setback dike, as Noel mentioned, is really kind of a compromise in balancing all of the goals of the project, as well as the constraints of private property and infrastructure. There was a groundwater component of the previous study, and really some of the bullet points on findings there is that the project restoration reconnection options really would have very little impact on groundwater in Tierra del Mar. The breach during average tide scenarios could result in potentially a 1/4 inch of increase in water table elevation. But during a major storm event, because the existing tide gate and culvert impound water and holds it there for a long time, a full breach or modern tide gate scenario, and particularly the full breach, would actually result in a small decrease in water table elevation during those major storm events. So as Noel said, after a long process, the OPRD selected the setback dike as the alternative for more detailed study and design. And that's really where we're at in the process today. The cross section you see below here, the orange is representative of the low point of the existing dike that's out there. And the larger cross section you see there with the higher elevation up to 15 feet, 15-foot elevation, and these broader side slopes are representative of modern levee design criteria and would be roughly the dimensions of a setback dike. So the goals of this project phase are really to refine these key elements of the alternatives through 2D hydraulic modeling and other considerations around alternatives analysis. Focusing really on the dike breach configuration and the setback dike location and sizing, as well as some interior habitat enhancements, which I will lightly touch today, but mostly focusing again on the setback dike and dike breach. And I will also provide a summary of the stormwater system analysis that we did. So this is a conceptual graphic illustrating these components where north is down in this image just for reference, but we're looking at breaching the Belts dike to provide hydraulic connection to the marsh and provide fish passage. The key here is to have an option for maintaining the trail, which the trailhead that exists here and getting access out to the rest of the trail network. So under a dike breach, how do we maintain trail connectivity? We're looking at potential bridges over a breach or boardwalk options to route a trail to maintain that trail connectivity. With the setback dike, we're looking at different locations for the potential setback dike and how each one of those locations would function, as well as what are the impacts to the marsh under those alternatives as well. And as we did a more detailed presentation on the Tierra del Mar stormwater and drainage system assessment last town hall, but I will go ahead and give a recap of that. You know, at a minimum, we want to understand how these drainage patterns interact with the marsh for our hydraulic modeling effort. And while we're at it, we wanted to identify system deficiencies and potential improvements that could be undertaken either as part of this project or as future county or community projects that can alleviate some of the existing drainage and flooding issues that occur in Tierra del Mar. This effort has really, you know, started back in 2015 and 2017 with collecting reports from individuals, from residents. We have, you know, starting under this process, we've been taking in a lot of feedback. I've met with a number of you folks at your homes and looking at your drainage issues firsthand, and as well as sharing, you've shared a lot of photos and accounts of what's going on out there. Back in January, I came out and again met with a lot of you and did a detailed assessment of the system and identifying a lot of the deficiencies and potential solutions. This is a overview of our drainage system assessment mapping, defining drainage basins, flow patterns, and mapping out the culverts and ditch networks. This view, you know, it's a little hard to see, but I just wanted to show this as one of the main tools that I was using during the drainage system assessment, displaying the elevation of the terrain as this as this color ramp that really pops out drainage patterns. And you'll see here, looking at the north end of Tierra del Mar, where we defined a northwestern drainage basin. And again, you can see a lot of these depressional areas, closed basins that have poor drainage connectivity. One of the main bottlenecks in the system is at the very bottom end at Roma Ave, the culvert on the Sand Lake Road ditch at Roma Ave. You can see here on the left, we're looking at the upstream side where that water level is impounded and backing up. And on the downstream side, at roughly the same time, the culvert is free flowing. It's not backwatered. It's not blocked, but it has low capacity to pass that water. So this is a bottleneck that could be upsized to alleviate that bottleneck and really get a lot of the system flowing better. I'm going to flip through a few examples of some of the depressional ponding areas that we see that just don't have a connection either to Sand Lake Road ditch or you know, good drainage connectivity to drain this water away. You know, there's some examples of undersized and blocked culverts that, you know, even when there's very little water moving through the system, they're still backing up water and holding on to water. Again, another video, or excuse me, image of some of the worst kind of ponding conditions there. Again, in this northwest basin that has very poor drainage connectivity. Here at the end of Gardenia, I've got a couple images here. On the upper right, you can see the drainage ditches that have been recently cut in there. And that was a fairly recent improvement that was made. And you can really see it in the LiDAR imagery as well as here at the end. But the purpose of that was really to provide a good connection of the side street to Sand Lake Road ditch. And this is an example of a pretty minor modification that could be implemented at other side streets to have a similar effect. Another condition is, you know, there's really long culverts in certain areas that at Holly Ave, for example, there's no way to get that water off of Holly and into the drainage ditch. Here we see, you know, one of the purposes of that long ditch is to provide, you know, this bus stop area. And so there are some options for trying to daylight these ditches, these culverts, and open up the ditch and provide better ability for the side streets to drain to the ditch. And this is a section right in the middle of that long culvert that got plugged and has been daylit essentially to have that effect. At Austin Ave, this is one of the most obvious examples of one of the closed basins that just has no way to drain this water away. Here in the upper image, you can see in the color depiction there, at the end of Austin, a really defined basin that, again, just has no way for that water to get out. So when you do get heavy rainfall, its only way to get out is to infiltrate, and often the water table is high as well, limiting that ability. The bottom image there is the far end of Austin where it connects to the Sand Lake Road ditch, and even at that end, there's really not that good of a way to get that water to the Sand Lake Road ditch. And then here again, looking at it in our drainage system analysis map, showing those drainage patterns, a closed basin, and inability for that water to escape. We've looked at different methods of trying to get that water out, and on Austin specifically, to get that water all the way over to Sand Lake Road, it's very flat. You would have a really hard time excavating a channel or a ditch to get to Sand Lake Road. We have also considered the option of putting in a drain in this western basin and draining it out to the beach with the new outfall. There are other considerations along with that, but again, just an idea for adding some drainage relief in areas like that. This is an example at the end of Coates Ave with the recent ditch that somebody has excavated, likely the landowner right on the corner there. Another example of pretty minor modification that does provide fairly instant relief to get water flowing to the ditch better. And Lake Eloise is another example, or excuse me, at the end of Eloise Ave, known as Lake Eloise to the residents right there, that another area that just doesn't have a good way for water to get to the ditch. There are some competing interests in, cleaning out these ditches and stripping away the vegetation and making them flow better would improve drainage, but of course, having that vegetation in the ditches does have a water quality benefit. So there is some competing interest there to address, but again, just an example of how those improvements could be made, and then what are some of the other considerations around making that decision to clear away the vegetation. One of the main problems that folks are having with the ponding that occurs there is impacts to septic systems. And, a lot of the traditional systems with drain fields underground are more easily impacted by that shallow water table and poor drainage. Many systems have been converted to elevated sand filters, which do have a lifespan and replacement timeline. And then, many of the newer systems that have gone in are advanced treatment systems that are functional under even those high water table conditions. So just to close on that and offer some potential improvement. So focusing on Sand Lake Road specifically, the Sand Lake Road ditch, really just maintenance and clearing a lot of those culverts out and clearing out the ditches on a regular basis could have some significant improvement. And next step would be actually upsizing some of those culverts. And as I said, specifically at Roma Ave, excavating swales and ditches along the side streets to have better connectivity to Sand Lake Road, which may require some raising of driveways or providing culverts at driveways. And then there are considerations for managing conflicts with utilities. So if you do excavate a channel or a ditch there are buried utilities. And as Bucks noted, a lot of the main lines being on one side of the road. So you could really focus on ditch improvement on one side or the other, but there would be some necessary improvements or adjustments to some of the utilities. And then, like I said, daylighting the long sections of culverts, which are prone to blockage and also prevent water from draining to the ditch. In the Northwest Basin, on the west side, northwest side of Tierra del Mar, replacing those culverts at Pollock and Jasmine Ave to increase conveyance. Some minor enlargement of ditches and swales, and there's a few spots where there's fill placed in that flow path that could be removed. and then other options for installing catch basins and potential new outfalls that could provide some drainage relief. So with that, I'm going to transition into the restoration actions that we've considered, starting with the dike breach. And again, around how big should the breach be, where should the dike breach be, and how do we maintain trail connectivity under those breach scenarios. Here you can see about 4 different locations where we considered for breach connection. The existing culvert and tide gate over there on the right side or the east side, 2 large paths in the middle that line up with historical tidal channel flow paths, and even considering other smaller connections on the west side of the marsh. We looked back at the 1939 aerial, the oldest air photo we could find, and you see these very prominent tidal channel flow paths and a lot of the modifications that had happened even in 1939 with the dike having gone in. We do see a apparent bolt access road down here at the south end, roughly where setback dike is being proposed now, as well as some remnant tidal channels here in the Reneke Creek area. Again, the main focus here, though, is looking at where to put the dike breach. And so, again, focusing on these primary channel flow paths, here's looking at today where those same, prominent channels still exist. We considered if it made sense to do one breach or multiple breaches, or what would be the benefit or disadvantages to considering multiple breaches. And essentially one of the biggest challenges to do multiple breaches is really the predictability of having multiple breaches in play. For example, if we did put in 2 breaches and 2 bridges, over time, one of those could become the dominant flow path. And depending on how those were sized, there would be potential for erosion at a new bridge location. If there was a way to make multiple breaches and have reduce the cost of bridges and trail accommodations, then that could be beneficial. But tidal channel networks generally drain to a single channel. They often exhibit this fractal dendritic channel planform, essentially a tree trunk with branches that all funnel down to a single channel inlet. And you see this all over the place. I've just pulled a few examples from the north end of Sand Lake where we see these patterns playing out. Even Sand Lake itself, you see the whole system kind of funnels down to its single inlet or to the ocean. And at each scale, as you zoom in, you continually see this pattern of this dendritic channel network draining to a single point. So I think, really all of this is going back to saying, I think if we are investing the money into a large bridge over a breach, I really do think we focus on a single dike breach sized sufficiently to generate the fish passage and velocity conditions that we'd like to see, and focus the investment in a single bridge. So as far as sizing a single breach, we started with an analysis of the marsh area contributing and the tidal prism volume, how much volume would move in and out of this breach on a daily basis. And using geometric relationships developed by PWA, a company that's now part of ESA, developed tidal channel design guidelines. And so we've used those guidelines as a basis for sizing a breach. And then as well as looking at, in our model, what that dike breach results in for velocities and how that would relate to fish passage and fish swimming abilities. Also, if we want to maintain the trail access over a dike breach, we would be looking at a pedestrian bridge. Bridges of about 150-foot span, that's reasonable to achieve with a single span. But once you get bigger than that, the bridges would really get quite expensive, and the thickness or the profile of a bridge structure would get quite deep and start to actually impact the cross-sectional opening of that breach. We also want to minimize the constriction for scour. We want to make the opening big enough such that it's not going to erode, so that we can protect a new bridge that's put in. This is a, the location, that interface location where we're considering a breach. And this diagram here shows roughly a 100-foot dike breach, the darker blue being about a 40-foot bottom width of that channel, tapering up to about 100-foot breach at the top with 100 to 150-foot span bridge spanning that. We would likely look at removing the existing failing concrete culvert that's there, and that's an area where there is significant erosion that would ultimately fail and breach itself if nothing was done. So likely would want to patch that up or reconstruct that area to allow that area to be maintained as the trail into the future. These are a few examples of the pedestrian bridges that we might look to for this sort of span. We would likely be looking at a steel pedestrian bridge structure, and these ones here, these are prefabricated systems. That's also a way to keep the cost down, to use a prefabricated bridge system. These are the two on the left, the steel ones are contact bridges, and I believe the bottom right is a Western Woods structure. But these can be achievable in that 150-foot span range, with the ability also to run a pickup truck, or if there's a need for access out to the west end, these bridges could also handle that light vehicular loading. Excuse me. We also looked at the potential for larger breaches or full removal of the outer dike. There would be some benefit for restoration under, to restore more of what the natural condition would be. And under that sort of scenario, how would you maintain the trail access? And so we've looked at potentially running a boardwalk from the existing parking lot and trailhead across the marsh, connecting over to Elk Knoll as one option. This also, though, would require several channel crossings, which essentially amount to bridges as well. We've also looked at potential of routing a trail around the east side of the marsh. But again, we get into several locations where it would be a boardwalk, would be needed to cross some of these wetland areas, and bridges to cross Reneke Creek area, Belts Creek area, and then ultimately the marsh, or connecting into a setback dike that could be constructed at the south end of the marsh. Some reference examples of a boardwalk of this type and this size and in a similar setting. The Nisqually National Wildlife Refuge has a very impressive boardwalk system made out of wood. And, we've looked at this as an example, also as some lessons learned from that project where, when they first put this boardwalk system in back in 2011, they had a 40-foot bridge span you can see up here in the upper left. However, over time, over the next, almost 10 years, significant erosion occurred, undermining that bridge and ultimately being replaced with a 90-foot span. So that's kind of a bit of a caution for us to not undersize the bridge, or, maybe necessary to replace it in the future. Wood boardwalks, there's a lot of concern around maintenance and longevity of a wood boardwalk. So we did also look into the potential of a concrete boardwalk system that would have a much longer lifespan and less maintenance, but also significantly higher cost. Here you can see construction of that concrete boardwalk system. So again, why are we even thinking about full dike removal? Really a lot of this is just looking at how to kind of maximize the restoration potential by removing that artificial fill that had been placed across the edge of Sand Lake. However, through our modeling, we've determined that a 100-foot dike breach or a 200-foot dike breach or a full breach really would have no effect on the water levels in the marsh. It would have some effect on circulation patterns of water, and I'll show you that in just a second. There could be a benefit of restoring wetland area within the footprint of that removed dike area, and potential to use that dike fill for the setback dike, though that would be logistically challenging due to timing of construction. The disadvantages of full dike removal, though, are impact to the trail. requiring, major modifications of boardwalk improvements and major trail reworking, and really the significant cost of that. The boardwalk option is estimated to be roughly $3 to $5 million to run a boardwalk of that size across the marsh. In addition to just removing all of that earth would have a significant cost, upwards of $1 million or more, compared to the options of just spanning a dike breach with a pedestrian bridge, much more affordable, I guess you'd say. With full dike removal, there could be some potential for water moving from Sand Lake into the marsh, and the remaining dike, if left in place, may have a benefit of acting as a wave break to water moving that direction. Here is some cost, really rough preliminary cost, but just to kind of give an order of magnitude, to replace, to breach the dike about 100 foot and put in a new bridge, we're roughly right around $1 million for that full option. A larger bridge, getting closer to $2 million. And for full dike removal with the boardwalk, we're really into that $5 million range for that sort of modification. And this is really just looking at the difference in water levels, and actually there would effectively be no difference in water levels under those scenarios. Here's a little glimpse of our 2D hydraulic model showing circulation patterns under a 100-foot dike breach versus full dike removal. And at most water levels, there would actually be very little difference, where water still is funneling into that main channel. And under the highest water levels, when the full marsh would be inundated, you can see a significant difference in how, a 100-foot dike breach still represents a significant constriction to water moving in and out, rather than water moving across that full interface. So certainly some differences in circulation there. We've also looked at the difference, how to size this dike breach. And our first starting point being a 100-foot dike breach. What we see here in the color representation is velocity. So the blue areas are velocities generally under about 1 foot per second. As we're getting into the yellow, it's about 2 feet per second, and even higher. We don't see any of it, but up to 5 feet per second would be in red. What we see here, this is the max velocity that we see under a 100-foot dike breach, reaching about 3 feet per second. However, through our modeled scenario, including king tides and a 100-year storm there as water levels get the highest, we're just barely clipping over 2 feet per second at most times. And even, most often we're well below 1 foot per second, typically. With a 200-foot dike breach, though, again, doubling that size, it would reduce velocities through the breach itself, but we would still be seeing velocities over that, 1 to 2 feet per second in the existing channels. Just for reference, the Whalen Island Bridge is one that I think a lot of folks are familiar with. That's an 80-foot span roadway bridge, and it's heavily armored. So there's some other considerations there around 180 acres of marsh contributing to this bridge opening, compared to about 80 acres in Sitka Sedge. This is an 80-foot span, so even a little bit smaller than what we're talking about for a pedestrian bridge, but you can see it's heavily armored to respond to the high velocities that do occur with this bridge opening. And so to summarize there, we looked at the 100-foot, the 200-foot dike breach, and full dike removal. The dike breaches could be spanned by a bridge, but full removal would require major trail modifications and boardwalk segments. The full removal would result in the most natural conditions, but would be significantly more expensive. And the 100-foot dike breach is sufficient to equalize water levels and keep velocities relatively low for fish passage. And it's unclear whether full dike removal would really benefit sediment accretion or sediment dynamics in the marsh. And often in restoration projects, berms can be used to slow that water down in order to result in sedimentation and increase accretion. Some other considerations for dike breach with pedestrian bridge is that, as we said, the outer dike is in disrepair. if the dike is going to remain as the trail into the future, there are some improvements that would need to be made ultimately. There are several trees that are threatening to fall over and potentially create holes in the dike. As we said, there are areas that are eroding and several low points that could overtop during current peak tides as well as into the future with sea level rise. And, certainly a lot of construction logistics around building a new bridge in this location, from foundation design and just construction access and impacts to get equipment and materials out there to build a bridge. So more considerations that would be looked into the future if this option is selected. So now I'm going to transition into the setback dike discussion. And, as I said, our prior study looked at a single location of a potential setback dike, roughly where the existing beaver dam is. And, that's this one here at the bottom, or the furthest out from Tierra del Mar. We have been looking at, understanding that there is some impact to putting in a setback dike in that location. And so both direct impacts to the wetland, as well as how much area of wetland would be left behind a setback dike. So some of this effort has really been focused at trying to reduce those impacts associated with building a setback dike, while balancing the functionality of a setback dike in that location to function during major storms, such as the 100-year event that we modeled. A setback dike needs to provide protection against the highest water levels in Sand Lake, while providing adequate storage volume to manage runoff entering behind the setback dike during large storms. And again, really wanting to minimize the amount of wetland impact associated with this feature. We want to also consider groundwater upwelling locations in the locations of the potential setback dike, as well as the geotechnical conditions, the subsurface conditions where these features would be built. And then also consider the tie-in locations on either side, tying into the west side, the forested dune, and then tying in on the east side at Sand Lake Road. The just straight across option would tie into Sand Lake Road at about 30 feet elevation. So a significant disconnect vertically from the elevation of the dike up to where the road is. So we've looked at some other aspects of that as well. This figure here shows the 4 locations that we've developed. And alternative 1 is really that starting point of a setback dike located near where the existing main beaver dam is. As I said, we've kind of looked at how can we reduce the amount of footprint impact, as well as how much area is left behind the setback dike. And so a lot of this study was really looking at how, progressively marching the setback dike to the south and seeing how that would function. Alternative 2 is about 300 feet south of the existing beaver dam, and alternative 3 is roughly at the park boundary. This was developed to look at what it would mean to route the northwest ditch that comes off of Tierra del Mar to the outside of the setback dike rather than behind the setback dike. And then alternative 4 is essentially pulling the setback dike all the way back to, raising Sand Lake Road up as the setback dike with a tide gate at the East Marsh culvert. We also looked at removing that tide gate and having a free-flowing connection to the East Marsh, and really seeing how these different options would function. Also as kind of a baseline. These are really representing the full range of location of setback dike or raised feature improvements, and wanting to see how all of these options would function. With each of these options, we do reduce the amount of wetland impact, but we also would reduce the volume of storage for performance during a storm. And noting that these setback dike alignments are in areas of heavy beaver activity, and there are implications to maintenance as well as functionality of a new tide gate in that location. And then alternatives 4A and 4B are associated with county roadway improvements and the pending replacement of the East Marsh culvert. This is a comparison of the wetland impacts under each of these options. So see at the top, existing conditions, there's about 82 acres of marsh behind Belts Dike. Alternative 1 would have a footprint impact of about 1.5 acres of wetland, direct wetland impact, and would leave about 11 acres of marsh behind the dike, behind the setback dike. You can see as you move the setback dike south, you are reducing wetland impact to the point of, you know, raising Sand Lake Road, really having minimal wetland impact. And then I'll show you now how these options would function from a hydraulic standpoint. So with all of these options, we're looking at where's the water coming in behind the setback dike, contributing to filling up of that basin during large storm events. And for reference, the 100-year base flood elevation is about 11.8 or roughly 12 feet. The low point in Sand Lake Road is about 11.6. I won't go through all of these, but really just setting a few of these benchmarks. The existing beaver dam holds water back at about 8 feet already. So the south end of the marsh always has water standing in it at about 8 feet. And that's what this represents here. This is kind of typical dry season conditions where Sand Lake in blue is rising up to the full tide level, but it never drops below 5.5 feet. Whereas all the way down at the bottom here, that's the ocean tide. So the ocean drops all the way down, but Sand Lake only drops to about 5.5 feet. So with this whole project analysis, we're operating kind of within the upper half of the tide cycle, and the bottom half of the tide cycle is kind of irrelevant for this analysis. During the wet season, we see generally the same thing. You know, the yellow line there being south of the beaver dam, where again water is always sitting at 8 feet. We see small peaks in water level during storms. But really never draining down below 8-foot elevation. This is actually monitoring from the most recent king tides in February, and we did a water level monitoring location in the East Marsh, so sitting at 8.2 feet, again, never falling below that. And what I wanted to also show is that, you know, back in 2017, how has conditions changed since 2017 when there was some of the tide gate remaining to now? And what benefit does the existing dike and tide gate have? So back then, the existing tide gate was quite leaky, allowing water to rise in Belts Marsh, but would typically lead to about a 2-foot reduction in the peak tide of water levels seen in the marsh. And now with the tide gate fully missing, water's rising about 1/2 foot higher than back then. So with that leaky tide gate opening, water is coming in to Belts Marsh. It still limits tides by about 1.5 foot, but we are seeing significant tidal influx under the existing condition. These are just some details on the hydrologic scenarios that we've developed, and with monitoring data, you know, we do have an observed event of 11.8 foot water level in Sand Lake. This really closely correlates to the 100-year water base flood elevation in FEMA floodplain mapping, and you know, interesting to note as well that the FEMA floodplain mapping does not recognize Belts Dike as a flood barrier. That 100-year water surface elevation bypasses the dike and propagates all the way back to Sand Lake Road within the FEMA mapping. We took real stream flows in Reneke Creek, Belts Creek, and the East Marsh, as well as runoff coming from Tierra del Mar. The real flow data was about 65 CFS peak, so about a 2-year storm in Reneke Creek. And we scaled this up to about 274 CFS in Reneke Creek to generate a 100-year storm. So this is the storm that we used for a lot of our analysis to really, how would this system function under typical kind of winter conditions, as well as the base flood and king tides with 100-year flows. So this is a summary and a lot of words here, but just to say that, the existing system now, it does limit high tides. It does moderate how much the tide can rise. But during storm events, the small culvert that's there really limits the drain out. And so during big storms, which we'll see here on this slide, the blue is the existing conditions water level in Belts Marsh during a large storm. So you can see under normal tidal conditions, it is limiting how much the tide will rise. But when you get an inflow of water just builds up in Belts Marsh. And then once we get these highest water levels, it takes many days to drain out. This shows actually all the alternatives that we looked at would perform better than the existing conditions under large storm events. And you can see that with larger drainage structures or breaches, water gets in quickly and can rise higher than the existing conditions, but it drains out very rapidly as well. And here with our 100-year modeling, so this is looking at water levels at the south end of the marsh, so close to Roma Ave, and under each of these alternatives. So we've got, and I've used consistent colors throughout. So hopefully, this will, once you catch on to the color coding, you'll understand what's going on. The gray line here is water levels in Sand Lake. So we do see high tides up in the 9-foot, 10-foot, and ultimately up to 12 feet under our largest tide that we included in the model, and water level never dropping below 5.5 feet. Back at the south end of the marsh, water level never drops below 8 feet, and that's because of the beaver dam that's holding that water back. And each one of these alternatives is in a different color here. So alternative one, again, is the setback dike near the beaver dam, the furthest one out north in the marsh. And I'm going to start zooming in so we can actually see the differences. Under essentially a 2-year storm, we do see the blue is the existing conditions here. So, it does prevent water from rising to the full height, but drains out very slow. And each one of these setback dike alternatives, the orange one here is setback dike alternative 1. That's the only alternative that actually has the ability to reduce water levels during these large storms compared to existing conditions. The other alternatives all would result in higher short-term peaks, short duration peaks, but they all drain out much faster than existing conditions. And here, it's really kind of a lot of the same story, that the existing condition, the existing culvert system, it just drains out very slow. So all of our alternatives really improve drainage during the peak storm events. But do result in short duration, higher peak water levels compared to existing conditions. So, just to kind of grasp the different alternatives here. So alternative 1 being the furthest dike out is performing better than the existing conditions. Alternative 2, where we push that dike closer to Tierra del Mar, is not performing as well. It's resulting in higher peaks. And then raising up Sand Lake Road and allowing that water to propagate all the way back to the south end of the marsh, we see the full tide occur back there. So rising all the way up to 10 feet or higher, and then quickly draining away compared to the existing conditions that holds onto water. And here, once we get into the king tide, so the existing conditions, again, results in the highest water levels out of all the alternatives, and results in very poor drainage that takes days and days to drain out. So really all these alternatives during the 100-year storm and king tides either result in the same water level as existing conditions or lower, and drain out much, much faster in all cases. But as I said, during typical tidal conditions and not large storms, those high tides would propagate back to the south end of the marsh. And so when there's not a significant storm moving through the system, the existing the existing dike and tide gate system do moderate those water levels and do prevent full peaks from reaching the south into the marsh, but again, do have drainage inefficiency. We tested the effect of rerouting the northwest ditch flow path. As I said, can we reduce the amount of water that would be flowing in behind a setback dike? But unfortunately, that area is so small compared to the East Marsh drainage that unfortunately doesn't have much effect. So the concept of adding beach outfalls or rerouting some of that water doesn't really change how a setback dike would perform. You know, it still could provide some benefit for relieving localized ponding in areas like Austin Ave, Pier Ave, and at the end of Jasmine, but really has no effect on how a setback dike would perform. Now here in the East Marsh, so upstream of Sand Lake Road, you also see that under existing conditions, you know, and here again, water never falls below 8.5 feet. But when we do get these large storms, water rises to 11 feet or 12 feet and sits there for multiple days at a time. Compared to all of the other options, assuming that East Marsh culvert is replaced with a larger structure, we would end up with water levels returning to the baseline very quickly due to much improved drainage. And so it's important to look at, you know, what do these 12 and 13 foot water surface elevations look like at the south end of the marsh? And, you know, essentially under alternative 4, so where, you know, we would be looking at raising Sand Lake Road up as the setback dike, or just as raised high ground responding to these higher water levels. And you can see here that we've got 11 feet in yellow, 12 feet in orange, and 13 feet in red, which we don't see those 13-foot water levels currently, but could in the future. And you see that, you know, a portion of Sand Lake Road is inundated at those water levels. The East Marsh has significant inundation, and the private property at the north end of Tierra del Mar would experience those water levels, and currently do under the largest storm events. This is essentially building out what alternative 4 would look like. So raising up Sand Lake Road to an elevation of 15 feet. The end of Roma Ave is at about 14 feet right now. So raising that segment up by about a foot with added culverts, upsizing the Roma Ave culvert and upsizing the East Marsh drainage culvert. You know, here's just a kind of a markup of what that would look like on the ground of raising up Sand Lake Road and the far end of Roma Ave. And then to understand how those water levels would interact with the existing culvert at Roma Ave. So the 12-foot water level is the bottom blue line, showing that water level just barely clips the bottom of the culvert at Roma Ave, and 13-foot, kind of a theoretical 13-foot water level would start to propagate back into the ditch, almost up to Pollock. You know, again, that alternative 4, what that would look like would be in orange is representing raising Sand Lake Road up to that 15-foot, slightly raising the end of Roma up about a foot with a much larger culvert to provide that drainage. And you can see that, again, that 12-foot and 13-foot water levels, you know, start to interact with that culvert and ditch. You know, thinking about long into the future how this system may function as well. You know, again, we don't see those 13-foot water levels now, and we certainly don't see 14-foot water levels, but we do want to show that, you know, under significant sea level rise projections, how alternative 4, or, you know, pushing the setback dike all the way back would look. And, you know, we certainly do start to see more inundation into the ditch, into the East Marsh, and onto that private property on the north end of Tierra del Mar. So again, you know, alternative 4 is really was a progression of marching the setback dike as far south as possible, and ultimately does become a non-setback dike alternative, just raising up the infrastructure to accommodate that, and acknowledging, and really also in response to some of the feasibility and constructability considerations that we're looking at for building a setback dike. a new setback dike would also have a new tide gate in it. And the way this tide gate would be set to operate, it would essentially stay open all the time and only closing during the highest tides. If that tide gate's sitting open all the time, and particularly in this area of high beaver activity, the beavers are likely, would be trying to block this structure. And there's also some potential for just sedimentation around a structure like that in this slack water setting where it's not really closing very often. There's also significant geotechnical challenges to building a setback dike out in this location. This is a cross-section of the Whalen Island Bridge, where you can see these different layers of fluvial and estuarine deposits, different layers of sediment deposits over time, with rock really, 60 feet or more down below the ground surface. And each one of these layers has a different level of compressibility, where if you place, fill for a new setback dike on these layers, we would expect to see significant settlement. This is just walking out across the area where we're talking about building a setback dike. And this is the ground surface where we're talking about building a setback dike. And just we were seeing the kind of pumping of the surface, and you see the rod that's been sucked down through this mat of cattails down about 3 feet. So again, challenging geotechnical conditions to build a new dike out there, and of course a new tide gate structure as well. So really just capping on some of the geotechnical engineering challenges, we would expect several feet of settlement along a new setback dike due to the weight of the new fill. Settlement at the new structure would be particularly challenging, and would, have, there are engineering measures to mitigate a lot of these challenges, but just acknowledging that this, is a tough location to build a new dike and tide gate structure. There's also seepage considerations and seepage analysis that would need to be done, and really a very substantial amount of subgrade stabilization. So, placing rock and fill and over excavating some of these poor soils. There's issues of sourcing material, and really that would just result in expense to find that material and bring it into the site. And then, as I said, there's issues of tying in, or challenges, I should say, and tying in the setback dike on either end, really looking at benching these into the existing embankments. And there's potential to cause settlement on Sand Lake Road where new fill is placed up against that embankment. There are also groundwater upwelling locations in each of these areas where we're proposing a setback dike that would need to be managed and considered for stability of a setback dike. And as we showed in that video, there are pockets of very soft soils and floating mats of vegetation out there that would need to be managed under those construction actions. In order to design a setback dike and understand these conditions and the new structure, even just collecting geotechnical data, borings out in these locations is very challenging. It's so soft, we can't get traditional drilling equipment out there to collect borings. What you see here are a couple examples of specialized marsh drilling equipment. This one here on the left is an amphibious drill rig that is located in California. There's actually no drilling companies in this area that have this equipment either. So I have received a quote of getting this rig out here and doing some of this drilling work is roughly $150,000 just to get the rig out here and do the drilling work to collect some of the data needed to design a setback dike and new tide gate. So some comparisons around the different some cost comparisons around these different setback dike alternatives. These are really responding to the difference in volume of fill required to build a setback dike in each spot. And so, essentially what we're seeing here is alternative one is the longest dike. It would have the most volume associated with it. It would have the highest cost of the first three setback dike alternatives. Raising Sand Lake Road has additional costs to consider of, being on a roadway and traffic control measures and, I guess the improvements that would go along with a road being on that raised feature, actually turning out to be likely the most expensive option, but would have significant improvements for county infrastructure in the process. And then alternative 4 includes county road upgrades that may need to happen in the future anyway. And so considering that under alternatives 1, 2, and 3, there's also likely additional cost to future roadway improvements that would not be captured in the alternative 1, 2, and 3 costs. So with alternatives 1, for example, at approaching $2 million to build that new setback dike and tide gate, there would also be likely additional roadway improvement costs in the future. So we got into, and then just to say, with the 3 setback dike alternatives, 1, 2, and 3, alternative 1 is really the only setback dike that would truly function as a setback dike with enough storage to lead to lower water levels during those big storm events. Alternatives 2 and 3, as we march them south, they start to not function during the large storm events, and we end up seeing those high peak water levels anyway. And so I essentially think that it's a decision between, moving forward with alternative 1, setback dike, roughly at the location of the beaver dam, or considering the raised roadway option if feasibility of setback dike alternative 1 were not to pan out for a number of potential reasons. So looking at really refining setback dike alternative 1 here. As I said, if you cut the dike straight across the marsh and try to tie into Sand Lake Road, and on the bottom here we see a profile. We've got the new setback dike at about 15 feet and the roadway surface up at about 30 or higher. And so what you see on the end there is about a 10% slope, which is actually similar to what we see at Whalen Island. If you're driving off of Sand Lake Road and you drive down to the Whalen Island Bridge, it's about the same. That would be about a 10% grade running down to there. We're also looking at where this dike would sit in relation to the existing beaver dam. And in what we're showing here, it's actually sited just downstream of the existing beaver dam, essentially leaving the beaver dam and the beaver pond, essentially, the beaver habitat behind it unaffected. We think for multiple reasons, this would be a good idea to try to leave that existing dam intact to really reduce the beaver's desire to try to plug up a new tide gate if we're essentially allowing them to continue existing where in the locations that they currently do. We've also looked at potential to, rather than cut straight across and tying at the high elevation, hooking the setback dike to the south and tying in where Sand Lake Road is at about 15 feet. So this does reduce the amount of storage, but could be more beneficial to tie in that location. However, another feature that we see in addition to the existing main beaver dam up here, there is an existing beaver lodge right here to the south, kind of tied up in this ditch network. And so there's other thoughts about, what are we crossing with this setback dike alignment, both from, habitat perspective, vegetation perspective, and in geotechnical conditions. As I said, there are pockets of really poor soils and really challenging areas to cross. This is a cross section at the bottom here of what that setback dike would look like relative to the existing land surface. So in some of the area that we're talking about crossing, the existing ground is at about 8 or 9 feet, and the new dike elevation being at about 15. We're talking about a 6-foot height of a new dike across that area. And then also to note that with these 12-foot water levels that we're talking about, the water would essentially rise on the outside of the dike. They would only be rising up a couple, maybe 3 feet above the existing ground surface. And so when you think of the dike retaining a lot of that water, I guess this helps to illustrate that the depth of water outside of the dike under the highest tide scenarios would really be resulting in about a 3-foot water depth up against this new setback dike. These are looking at Sand Lake Road and what these, potential tie-in locations may look like. And then again, really kind of moving into this next step of this next set of slides of just on the ground conditions, what are we talking about? This area here is up again where Sand Lake Road is at about 30 feet, tying a dike into this elevation and cutting across the marsh. And now looking at the area that would be crossed with a setback dike. There is this bedrock outcrop out there in the marsh that some folks may know about. That's pointed out in the arrow there. This is facing north. We're a couple hundred feet south of the Beaver Dam right now. This would be about where setback dike alternative 2 would be crossing, with setback dike alternative 1 out in the background there, past the bedrock outcrop. Here, the yellow arrow pointing down at the existing beaver lodge that's present on the ditch network. And again, just kind of representations of these are the areas that would be crossed by a setback dike. This is roughly where alternative 1 setback dike would be, facing south here and looking at the main beaver dam there with the red arrow on it. So this would be, again, locating the setback dike downstream or north of that existing beaver dam and crossing the main channel and this wetland area, and then tying in to that forested dune on the west side. So again, really just looking at, this is the area that would be crossed, and this is the wetland impact area that we would be talking about. Important to note that while there's the main beaver dam that I keep referencing, there are other beaver dams in this system further downstream. This is, standing roughly at the main beaver dam and facing north towards Phelps Dike, and you can see another fairly prominent dam downstream. And so again, where this setback dike would be between 2 beaver dams, and again, in area of heavy beaver activity. There's some questions of whether or not the beaver activity would persist after tidal reconnection, and we think it likely would. There's a lot of evidence both in Washington and the Puget Sound of beavers existing in tidal environments. And, I know from Miami River Wetlands restoration project that we worked on a number of years ago, is tidally influenced and has a lot of beaver activity in areas where beaver dams do overtop during high tides. And so anyway, just to say that even the beaver dam downstream that would be subject to new tidal inundation, would likely persist, and certainly the beaver activity would persist. This is a closer look at the forested dune where the setback dike would tie into. So, not necessarily wetland impact, but certainly vegetation impacts. And actually, Malia's wearing a green jacket. You can barely see her in the very center of the photo there. So just for scale. But again, this would be an area where the dune where the setback dike would tie into. Did a little bit of a look at the vegetation that would be crossed. And, generally speaking, Sitka sedge has very high quality wetland vegetation. There's a few areas that have poorer quality and kind of this gradient showing green and excellent condition down to red and poor condition. And so, this area that could potentially be crossed is essentially the one spot in Sitka sedge that has reed canary grass, and so an area of kind of poor quality, but otherwise, what would be crossed is very high quality wetland vegetation. NOAA has a vegetation inventory back from 2016 of very high resolution plant communities. So where we start to talk about where do we run the setback dike through, we really have pretty good idea of the plant communities that would be impacted by that action. And then the other big aspect or challenge of a new tide gate structure in this area is how the beavers will react or respond or behave around it. Beavers do plug culverts and they can impact functionality and closing of tide gates. Beavers, plug culverts when it's beneficial for their habitat to create additional ponding area. And this certainly does have drainage implications and flooding implications if a new structure goes in and it gets plugged up, or the tide gate is prevented from closing due to debris that can impact the functionality of that system. And of course, that all nods to the maintenance implications of that, and how a new setback dike and new tide gate structure will have a real maintenance commitment in the future. There are things that can be done to mitigate the effects of beaver activity. Again, just where do we put it relative to the existing dam, and is there strategy to that? Making culverts wider culverts are harder to plug up. Deeper channels in culvert areas are harder to block, and essentially it's thinking about what features would we implement to make it harder to block. In addition to that, there are beaver exclusion measures such as beaver deceiver or beaver exclusion fencing, and then allowing or encouraging damming in locations where it's acceptable. As I said, if we site the new setback dike downstream of the existing beaver dam and kind of let the beavers have that south end area, maybe that would make them less likely to plug up the new structure. Here's just a few looks at some of these exclusionary measures that could be implemented. And, there is a lot of developing guidance of, how to live with beavers in these sorts of landscapes. Of course, beaver removal is a potential option, but not a permanent option, and really conflicts with a lot of the restoration goals of a project like this. Again, these are, some of the original beaver deceiver devices are on pretty small structures, but for larger kind of box culvert type of structures, these are, the sorts of measures that can be implemented to keep beaver from accessing the area and plugging it up. Again, some other examples, and we'll reference Skip Lyle of Beaver Deceivers International out in the Northeast, the inventor of the original beaver deceiver, and a lot of these devices have been developed based on that design. This is an existing tide gate up near Bellingham, Washington, a site called Smuggler's Slough. And these folks have put in, this is an MTR controlled, a muted tidal regulator controlled tide gate in a setting almost just like this, set to stay open most of the time. It's subject to constant inundation and in an area of high beaver activity. This was on a road, and so it's relatively easy to get to, but they have some major maintenance issues with the system, and have put in different exclusionary measures around it. They've had maintenance events where they've had to bring out excavators and vacuum trucks to suck out the sediment and debris placed by beavers around that gate. And again, not that it's not possible or not, ways to address this or maintain, but challenges that need to be understood for the setback dike alternative and a new tide gate in this location. ODFW addresses beaver exclusion devices, and so there's fish passage implications with those exclusion devices as well. And again, really just kind of nodding to the maintenance that would be required. Alternative 1, setback dike is located downstream of the main beaver dam. Alternative 2 is really right in that, heavily ponded and backwatered beaver area. Alternative 4, new culvert at St. Lake Road is, also subject to beaver blockage, and the existing culvert there has a kind of beaver exclusion cage on it. So just to summarize on the setback dike alternatives, alternative 1 performs better than existing conditions during daily tides and storm events. But at that, it does have wetland and vegetation impacts associated with it and significant geotechnical challenges. Alternative 4 would be less challenging to build and maintain, less wetland impact, providing more restoration, but it would increase potential or would increase the frequency of tidal inundation on two properties within Tierra del Mar and Sand Lake Road, being raised up to respond to that. And so, that really concludes the presentation of content. And, our next steps here are obviously to open this up to discussion and answer some questions here in this forum. As Noel said, OPRD is soliciting feedback and comments through their website, through the project webpage. Again, search online, Google Sitka Sedge hydrology, and you'll have an opportunity to submit comments. Ultimately, after hearing this information and collecting feedback, OPRD will be working to finalize the decision on the preferred alternative elements at the dike breach and at the setback dike. And then our team will be working to advance the preferred alternative to 30% design with some additional geotechnical investigation to design a setback dike and tide gate structure, and also the new bridges or other features have structural and geotechnical design components. Tillamook Estuaries Partnership is actively and continuing to apply for grant funding to fund final design and ultimately construction, and continuing to work towards implementing this project. So thanks everybody. I know that was a lot of information and hopefully helpful and enlightening, and certainly I'm sure raises many questions. Really appreciate your interest and time today. And yeah, I'm happy to open it up for questions and discussion. Hi, Isabel. Yes, that's you're understanding it. So like I said, our process was really to start with alternative one and see, how far south we could push a setback dike and how each of those conditions would perform. And the most extreme version of that is bringing that feature all the way to the south and essentially raising up Sand Lake Road. When you think of alternative 4 as a setback dike, it would have a tide gate preventing those peak tides from propagating back into the East Marsh. But then yes, alternative 4B would have no tide gate there. And so it is essentially not a setback dike. It's breaching the dike, allowing that inundation to occur, and then raising up Sand Lake Road and the far east end of Roma Ave to respond to that. And as you noted, those inundation levels, sorry, get to my slides. So yes, under that reconnection option, these water levels, particularly the orange 12-foot water surface elevation, would occur during those peak king tides. That's also the water surface elevation that occurs under existing conditions during large storm events, when water drains into Belts Marsh behind the existing tide gate and dike and doesn't drain out. And so these water levels are not higher than what would occur under the existing condition, but they could occur more frequently.
So as I said in my introductory remarks, this alternative is not something OPRD was aware of before a couple of weeks ago, and this is not something that we embrace at this point. So what we are interested in right now is the true setback dike alternative, and that's what our agency commitment has been to this point. And if it turns out that alternative 1 is not buildable for some reason, we'll reconvene with all of the stakeholders and go through a process like we did in 2019 to identify what the fallback solution would be. But alternative 4 is not an alternative in OPRD's perspective right now.
Yeah, and to that point, like I said, this has been an analysis process of kind of bracketing the conditions. And during the previous phase, the full dike breach option was evaluated at a high level with called a bucket model, hydrologic budget model. And so this is essentially recapturing that same alternative with the 2D hydraulic modeling and looking at, what that level of inundation would truly look like on the landscape, how it could be responded to. But to Noel's point, we understand the decision was made during the previous study to focus on the setback dike alternative. And so from setback dike alternatives 1, 2, and 3 are really, we're looking at how each of those would perform. And ultimately it's alternative 1, setback dike alternative 1 is the setback dike alternative that is feasible. Yeah, it's the most expensive one as well. Alternative 4 is the most expensive option as well. Correct. That this is a comparison, cost comparison of alternatives 1, 2, 3, and 4. And then this was really saying that, if you do alternative 1 without touching Sand Lake Road at all, we're talking about the cost shown in table 1, but acknowledging that the county is interested in replacing the East Marsh culvert as well, and likely doing some road improvements there as well. And so alternative 4 would kind of do all of it at once, raising the road, replacing the culvert all at once and raising it up to respond to those higher water levels. Whereas alternatives 1 through 3 would do nothing to Sand Lake Road, even though there is potential for additional improvements at Sand Lake Road in the future. Yeah. Malia?
Yeah. You want to take me back to that other figure with the modeling with the water's coming up? And then
Yeah.
okay. Yeah.
Talking about this one?
Perfect. Okay. I'm going to point out one thing that this is not showing, and then I'm going to ask a question of this group, because this was what was raised at our last technical committee meeting. But I would like to point out that this modeling does not include the potential stormwater drainage also trying to come off of Tierra del Mar on our ditch next to Sand Lake Road. And we all know what happened when the ditch got all cluttered with all the trees and the heavy vegetation and the flooding that we were experiencing from having the ditch not functioning properly. And so we have that same potential occurring with the water not being able to flow through the ditch into Sand Lake Road because it reaches the same 12-foot contour elevation as the Roma Avenue ditch. So their computer modeling doesn't pick up what could happen up above from Sand Lake Road. And the one, Greg, you wanted to ask a question?
I just want to make sure that clear what you're saying is
Okay.
the water is coming back up the ditch.
Right, we have
That is going to impede the flow of water coming out
the ditch, right. So we have, during these big storm events, we have water that's trying to, surface water and groundwater is trying to discharge this way. And at the same time, we have the water coming up and it converges at Roma. And if the water can't flow out of this ditch down here, then this water in the ditch is going to back up into Tierra del Mar. And we've got pictures of the flooding that was occurring when we had one of those situations before they cleaned out the ditch. And so when, at our last technical team meeting, when we were talking about alternative 4, one of the questions that several of the people raised is, well, what would Tierra del Mar think? Or these private landowners here that truly, you know, the modeling shows will be flooded. Well, you know, would they agree to some level of periodic flooding every year? Or, you know, would Tierra del Mar be happy with a little bit of flooding? So the question that I want to ask you and take back is any level of flooding acceptable? If it is yes, then what level of flooding in Tierra del Mar would be acceptable under alternative number 4? Because that's something that the technical team needs to know from the community. Okay, so poll, what, Greg?
Yes. Well, okay, this doesn't directly answer the question, so maybe I'll raise my.
All right, so those people who say no acceptable flooding of Tierra del Mar, even on maybe, you know, definitely the 2 private properties, raise your hand. Okay, those who think flooding is okay.
Not.
No, it's right. It's not all tier. Right. But if you could. Yeah, you're right. And do we have a picture of the Tierra del Mar? A map that shows. Right, right. But when our ditches were clogged, we live on, our cabin is on Gardenia, and we're halfway down Gardenia, and we had flood waters going past our cabin on the road. And in 1996, we never flooded in all of those heavy rains of the 2 big 96 studies. And as soon as the ditch was cleaned out, we have never had any more flood waters coming up that far. So, and 2 streets north of, no, 2 streets south of us, there's a house right next to Sand Lake Road that every winter they would sandbag their driveway and their road because they sat right next to the ditch. And since the ditch has been cleaned out and maintained, they no longer put their sandbags out every winter. So that's the level of flooding that I'm talking about, that it would actually, you know, and I'm not talking about the depressional wetlands, you know, Lake Austin and any of those. Those are going to fill up unless we actually do something. Do that. Okay, so basically the answer to take back is no additional flooding other than what naturally occurs now is acceptable to the community of Tierra del Mar for alternative 4. Okay, great.
You know, I think I just wanted to point out that I think process, you know, again,
Mhm.
and that was, you know, the decision process didn't require buy-in by the Tierra del Mar. And so the selection of the setback based on the consideration of alternative. So now, you know, we're kind of, you know, we're ratcheting this, you know, it almost is sort of feels like the process is sort of moving towards, you know, it's like, well, you know, we got the agreement that and then, well, we have so, you know, we're moving towards alternatives that are, you know, more likely to be harmful to the community. And I just looks like where we're heading with this whole presentation. Our Parks Department, it seems to be kind of headed to, you know, the concept that was originally agreed to, accepted by the community, you know, based on all the considerations and balance of all that.
Right. And I think one thing that, I'm also still serving on the technical team, and I'm also on the Watershed Council Board. But, you know, a lot of the people who are now on the technical team, there are a specific core of those people who were critical or heavily involved in obtaining the funding to buy Sitka Sedge so that it could be, you know, provided to parks, so that we do have this golden opportunity to create this really nice park and preserve this as a natural preserve. And when that original purchase was going through and all of their thought processes, these people's goal is then and is still now a full breach of that dike. Because in their minds, we have, and this is true, we have lost a lot of our saltwater estuaries. And in their minds, this is one of the few opportunities that we have out there to breach a dike and restore an area of natural wetlands. And I think the challenge we have before us and the way to maybe rephrase this and relook at it is, let's not focus on breaching the dike as our focus and our goal and trying to restore wetlands. It's stepping back and looking at what solution can we come up with that is going to provide good fish habitat and work with the system as it is in maybe a more natural way. I mean, you go out there now and the beavers are doing a phenomenal job of changing all of that. And now that our elevation stays at 8 foot, you know, we haven't gone back and studied to see how our water temperatures are doing. And when we were out hiking all of that this winter, we dropped down off Tierra del Mar, and there's all these little itty bitty Sitka sedge trees or Sitka spruce trees are now thickly coming up. So we actually have a brand new baby Sitka spruce forest starting to develop. And the question is, what would happen if we start working with the beavers and we let some of this naturally evolve, you know, solve our fish, you know, transport across the dike now in some way that would solve our velocity problem, maybe 90, you know, 100% of the time, do the 100-foot breach, put the bridge in, figure out a way to make things work. Or maybe we accept the fact that if they're asking us to accept the fact that we're willing to be flooded part of the time, can we work with the fact that maybe we don't take out 100 foot of the dike, maybe we take out a little less of the dike, accept the fact that there's just going to be periods of time when we exceed the fish transport velocity. You know, maybe we can start rephrasing some of this stuff, looking to find a different way. And because this is a very unique fish habitat. Fish that we're targeting here for growth and development are the small fries and the juveniles. And they're wanting a habitat where they can go back and forth between the saltier side and the fresher water side. And the best example and the most successful part of that type of habitat is if you go down to Salmon River estuary. Of that whole big estuary, there is one little itty bitty pocket that the fish love. And it's the most successful and most productive for fish habitat as they're trying to go through this. And what's interesting about that one little pocket's habitat is that's the one that is the most impacted with groundwater flow into it. And our system here is very similar to that little pocket. We have a lot of groundwater flowing off Tierra del Mar, in which the Rex Haddock is septic, but it's got another purpose. And that discharges, and that when that fresh groundwater discharges into Sitka Sedge, it's creating part of our fresh water, especially in the summertime. And it's also bringing the cool water the fish want. And the fish aren't stupid. If you ever fish, you look for where, if you ever want to fish and really catch the fish, you figure out where the groundwater is discharging the stream in the summertime, because they're going to be there. That's their location. That's what they're doing now. And we need to start looking at that more here, I think, help get it done. But I'm just trying to say, yeah, we're, you know, we have a lot of pressures in the technical team for a full breach still. We have a lot of people who are not even happy with the 100-foot breach. And it's because they're coming to this with their still long-term held belief that we busted our butts, get the money to buy this for this one purpose. So, yeah.
Too bad, I lost my butt. But I'm very nervous. One thing about, you put a 100-foot breach in there, you're taking out a buffers that we relied on years. And you don't get two chances. It's one of the big times. It isn't about that it's going to break fast. It's more of a deal. It's going to wipe us out upstream. Very nervous.
Well, that's why we've got to figure out. I think there is a solution. I think there is a good way. It's really good. Great, awesome fish habitat, and not necessarily who, you know, where we're at.
You don't think it's that alternate ones.
He was pointing out, and it's just we're so up against it. And I'll tell you what, it was a real attention to be out with Hunter and us walking on water. I mean, we literally were walking on those cattail mats, and we're sitting there and and you're standing there going, okay, I am probably suspended in air 5 or 6 feet, you know, above the ground. What's going to happen if this fails, you know? And we learned how to pull the cattails across as we walk to create the mat area for right? Yeah. You're fine. Yeah, could you go back to that? That was at the very. There, okay, yeah. So what we're talking about is.
The 40-foot is the bottom width of the channel. So that's you're cutting a 40-foot channel and then roughly 2-to-1 side slopes coming up from that 40-foot channel. By the time you hit the top of the dike,
It's at 100.
it's about 100 feet wide.
And that would be right here. And that's the one that if we breach the dike at 100 feet, as Hunter showed, that's where the modeling shows that for majority of the time, the flow velocities through that cut would need the, what is it, 2 foot per
2 feet per
2
second,
feet
right?
per second. Okay. If we start narrowing down on that, then we start increasing. And I did some math for our grading committee, and I was showing that in the summertime, I was looking at the 2 10-foot dive gates, that if we did the 2 10-foot dive gates in the summertime, they would never probably close, or maybe one day a month they would close. I think somewhere in there was the balance.
Hundreds of that, point of whether, say, it was 40 or 100 feet wide, that's, correct me if I'm wrong, but that wouldn't change the water level height behind that setback for the original current dike, even if it was 40 or 100 foot wide, it's not going to change the groundwater level between the setback dike and the existing dike. It will just change the velocity of the water.
How much is it?
Right.
Here. Oh, absolutely.
Right, but it wouldn't.
Right, so-
That water level is stay the same.
It is. And I guess if you think about, you know, again, kind of going back to just how do you size this breach? And, you know, the idea of opening up a large enough gap or a large enough breach to really for the goal of fish passage. So creating velocities through that opening that are low enough to be conducive for fish passage, but also not such a constriction that we have high velocities and potential for erosion. For example, if we put in a 40-foot wide breach, like, yeah, you would get the water coming through that breach and filling the marsh, likely to about the same elevations. The water would be moving so fast through that opening that not only is it challenging for fish to move through, but it would have a tendency to want to enlarge already. And that's what we saw in that example at the Nisqually National Wildlife Boardwalk, where they started with a channel 40 feet wide, but just due to the natural hydraulics of that water moving in and out, it reaches an equilibrium. It tries to open itself up to a size that would be stable. And so if we went with a much smaller breach, again, the velocities would be higher, but there would be much more erosion potential. We would end up having to really place a lot of riprap armoring and go through much more extreme measures to keep that smaller opening stable.
Whale Island.
Yeah.
Whale Island. One of the residents here last winter shot an incredible drone video of the water. The swirls and the water. You know, I think we just need to start putting that. Some kind of phone calls to come up with it. And believe it, I do this also. I think we somehow, but here's what I agree with you, we can put it in the 5 years. I'm really deep about fixing it. So I'm not convinced. And we just have to figure out a way to reduce erosion. For velocities. I think that was a really nothing.
Yeah, as far as the alternatives, I feel like the alternatives seem to be creeping away from what we read on the board. OPRD is that's not what we're after. I see this a sort of like when you're looking for this this is we're trying to find the sweet spot. I think what we found out is analysis. Alternative one, sweet spot. So that's how I see this. Not a big exploration. Could we maybe increase the size, footprint, setback?
That's why it's called alternatives analysis. Don't go through it all. Alternatives don't start handing out. Then we go back to the board. Alternatives, we just don't like realize our people involved in our group who, you know, we just ask them to vote. Right now, I can tell you they're going to vote on 24.
You know what? But
I also think it's important to recognize that while the technical team is in place to discuss the scientific merit of all the solutions, there's no voting in the technical team. This is the decision that you already see how we're not having a vote here today. We want to hear what people are about and hear people's there's not most of the group of people that are making.
and it would be, That's how we got. If it turns out. Thanks. It could be the alternative one. It's not.
Right, you know, with the initial sighting of the setback dike, roughly at alternative one, you know, that was the concept of a setback dike came up during the tech team process and during the, you know, post, you know, really essentially after our work was finished at the end of the last phase of work. The setback dike alternative came up as an idea, and very little analysis was done on a setback dike at that time. And so what's going on here is, you know, a line was drawn across the site and saying, okay, let's put it roughly at the location of the beaver dam. And that's about, you know, the level of analysis that was done, you know, looking at how big is that basin behind that location, and would there feasibly be enough storage there to make a setback dike work? That was about the level of analysis that was done at that time. And so this phase has really been, you know, as Noel put it, kind of optimizing the location of a setback dike for that performance. And, you know, as I showed the photos of the location where alternative one crosses, you know, there's an acceptance that there would be significant wetland impacts, you know, acre and a half of just footprint of wetland fill across that area. And so with that in mind, there was a desire to see, can we reduce that impact and still have a functional setback dike? And that, you know, that process was really looked at in these different ways of pushing it, you know, halfway back, pushing it back further and trying to route more water outside of it, pushing it all the way back really as that, you know, recreation of that bookend condition of the dike breach option and what would be associated with making that feasible. But it really was you know, presented as a bookend of what's possible for where this setback dike alignment would be, and really targeted at, again, seeing if there is a way to reduce the amount of wetland impact associated with that feature while still having it be functional. And as we said, you know, alternative 2 and 3 do not function as a setback dike. And so that didn't pan out. You know, they do have less wetland impact and were worth taking a look at, but they didn't pan out. And so again, alternative 1 does function as a setback dike and has the ability to reduce water levels during daily tidal conditions, as well as during the big storms. And again, you know, the previous analysis and just comparing to the existing conditions is important to note that the existing conditions were, even with the dike all the way out at Belts Dike where it is, when you get the 100-year event coming through and the small tide gate drainage structure that's out there, we end up with these 12-foot water levels in Tierra del Mar anyway. And not only do we end up with those water levels, but they sit there for days and they don't drain away. And so yes.
Your data is
big mistake. Big. Very wasteful, insanity, store.
And that's a way to maximize the money that, well, it's a way to maximize our best fish habitat. When I was doing this study, I call them Trinity Creek is the one creek that has the best, most fish habitat. It is limited to 5 miles up, but it's the one that actually had where the population go up and come back down again. And what was interesting is they did not put that diversion point on Trinity Creek and had it outside of the dive until sometime around the 1950s, something like that. The 1970s are a photo that shows before that it was coming in. So there's a reason why it was too small. Now it's so originally that was a bridge. And I've got a picture in the 1940s showing, the Bill Bar and showing the bridging existence.
I go back a long way. I go back.
So it's not, and they put in the culvert that's there now. And the culvert that they put in is on this underside, wrong side culvert for the stormwater flows that we need to get through the area. And then it's right. Right. You see, the best thing to do is to put a bridge across on any feet. Don't get me started on all the problems that's routing now. And then, well, we have two options. One is we need to put a bridge somewhere on Sand Lake Road so Trinity Creek can flow underneath Sand Lake Road. One of our options is actually to come in and redivert over and put more down at a different place, where our parking area is, and then run it past Buck's place, and then connect to the existing channel that comes up on the outside part of the dike. And if we do something like that, we're just taking our best water for them to go down anytime they want, 365 hours a year, 24 hours a year. That's really, we're maximizing it. And then our next is salt water and fresh water is forming as these beaver dams are forming. And when I first started on this project, we had one of these. A couple of years later, we went out on the beaver dam. And now that they're progressively working themselves, really well. And I just wonder, and every time, and we know the water quality, fish love it. Fish, beavers, cobalt, they're happy with each other. And so I don't know, maybe there's a way that we can work with them. They're good engineers. So yes, I think you're right. I think rerouting all the time in connection with the fish is one of our easiest fish habitat restoration projects on the outside of the right, and we
Because if you reach the system belt,
that's a real point. Because one of the problems, and where this is real close to water here. Ditch from here down here, I don't think that's fine. And I think what happened was we go through here and then you can see these drainage channels, very
Yeah,
and then all of this here. Steep slope down. And it's all
right here,
well,
behind that.
right, there's a culvert.
It wasn't there in 1939.
We just put in a bridge up here, a walkway, a short bridge,